right, great to see everybody. Thanks for joining PlatformCon. Really good to see everybody. Yeah, just gonna get kicked off here. Yeah, this is my talk on building your own IDP with Kordent and Backstage. Just kind of get the ball rolling here. So just kind of a little disclaimer I gotta say here is like I'm not doing like a sales demo or anything like that, so just getting that out of the way. So a little bit about me here. So my name is Trenton. I am a consulting architect at Mirantis, and I do a lot of Kubernetes and kind of platform engineering type stuff internally. I work with a lot of very wide variety of teams between development teams and operations teams to kind of just build out and kind of set up infrastructure for people. Huge advocate of using Kubernetes and cloud native declarative kind of platforms. Yeah, that's a little bit about me. I just kind of want to give a quick rundown as to what kind of this workshop looks like, kind of what the goals are, things like that. What it's going to look like. I do want to say this is kind of just a proof of concept at this point, not really like a solid like product. I'm not trying to build something specifically that you can absolutely take this and move off of it. Everything obviously is going to be very open source. We don't want to, we're not trying to lock anything in, but it's really just kind of like demo functionality and core functionality. And really the reason for that is because Kordent, for the most part, is a platform that's designed to be very extendable and flexible. And we feel like Backstage and kind of IDP interfaces are actually a really good use case for more of a front end for Kordent, right? So if people want to kind of be able to build basically the existing open source tooling gets you 90% of the way there, which is kind of really cool. So yeah, so today I just kind of want to go over just a quick kind of deployment of what that looks like. There's a couple parts to this. We'll end up kind of deploying Kordent and Backstage into a cluster and then exposing the services. It's going to be a little bit, I'll say not production ready, the way we're going to actually be doing. We're going to be doing a little bit of kind of, well, I guess hacky would probably be the right way to put it, but it's definitely going to be there just to kind of demo, show the proof of concept so you can get in, kind of see what the interface, see what this stuff looks like, and kind of get an idea of what the workflow looks like. And then hopefully by the end of it, we'll be able to actually use Backstage to deploy a cluster. So yeah, oops, wrong button. All right, so before we get into anything, I want to back out here and just talk about like what Backstage is, and then just to get an idea of what kind of the tooling we're working with. So if you're unfamiliar, which it's Backstage is pretty popular, but it was created by the the Spotify engineering team, and the Spotify engineering team essentially released a framework, if you will, for building IDPs out as an open source project. Really, the great thing about it is that there's software catalogs kind of just baked into it, templates, all that kind of stuff, which really kind of matches the patterns we see. We kind of have with Kordent too, and we'll get into that a little bit. And then it also just has like just a gigantic like plugin ecosystem. So it's huge. It's very extendable. It's very open, very modular, and kind of fast to do these. Get up and running. You don't, again, it kind of gets you the 90% of the way there, which is pretty cool. So, all right, so this is kind of what the Backstage plugin kind of interface looks like. Essentially, you have like these core UI components, which you kind of change. Don't worry about the picture. But you essentially we can add in our own kind of service catalog plugin interface, and we've been toying with this idea. And kind of inevitably, we'd like to create quite a few of these for the Backstage ecosystem ourselves. I think that would be kind of wonderful to do and kind of contribute to and get things up and running. We'd like to kind of get some feedback on that. So just as an idea here, we're Backstage it pretty much look like this, but we'll be kind of focusing on just the standard interface for it. Okay, so a little bit about Kordent then. Kordent is kind of our platform. This slide is interesting. So Kordent is kind of our response to the cloud ecosystem, of course, in the beginning is incredibly complicated because everybody's got their own interfaces, they've got their own APIs, they manage storage in a different way. Everybody, from on-prem to in the cloud to AWS, Azure, all that stuff gets kind of just crazy. They have their own APIs, and you really kind of have to manage all the glue internally that handles everything. And so the cloud ends up creating a lot more complexity, and especially if you're going multi-cloud, where a lot of, of course, these providers really don't want you to be doing that. That kind of creates a little bit of a headache, right? So it creates a lot of additional complexity. And so people usually end up kind of getting locked into a platform, or they don't really have the ability to move even like in hybrid cloud setups, right? So they can't do their on-prem or and in cloud. It's just incredibly complicated. So Kubernetes is kind of the great thing about that, is it kind of simplified a lot of our API access in each of these environments, right? So we have simplicity in each of these environments, but the way these Kubernetes clusters interface with each other still is a little bit, let's say, uh, it's still Wild West, right? So you still don't have that centralized management control plane of all of your kind of infrastructure here. So this is kind of where Kordent comes into play. Kordent is our multi-cluster management utility. It is the control plane for all of these various Kubernetes clusters across many cloud region availability zones. Kind of just all over your architecture, and just simplifies everything under a common standard interface, which makes it just wonderful for using. Obviously, we can leverage great things like declarative patterns, immutable and idempotent and composable infrastructure, really great. And we can not really worry as much about the underlying infrastructure or who we're being provided by, whether it be on-prem, GCP, Azure, AWS. None of that really matters that big of a deal, because we kind of are just going to be focusing on, especially for the platform engineering side, one kind of common API to rule them all. So that's kind of the wonderful functionality that Kordent provides. So a little bit about kind of from the technical deep dive aspect of what Kordent is. So Kordent does two things. It does what we like to call KCM and KSM, which are the Kordent the cluster manager and the state manager. And so these are propped up specifically by CAPI and Sveltos. So we use CAPI as kind of a way to deploy and manage downstream clusters. So when we'll create environments, we use a wide variety of CAPI environments as part of Kordent. We'll do that, and then we'll also pull in Sveltos. And Sveltos allows us to, when we're deploying these downstream clusters, we can also add on specific like Helm charts kind of thing, applications for specific deployments and versioning related to each cluster we actually deploy. And then we kind of simplify this under a cluster deployment interface. So essentially, we provide the ability to, Kordent here kind of provides the ability to create these cluster templates and these service templates, which are just kind of like infrastructure managed interfaces for, so the provider, like the platform engineering team, would create these templates, and the developer could then create what are called cluster deployments based on these. And so cluster deployments allow us to only utilize certain service templates and certain cluster configurations. So say your infrastructure only has AWS, for example, right? You set up a cluster template for specifically the AWS, and here's the nodes you need for those kind of things. And the service template would be like, okay, these are our pre-approved applications. These are what have to be there. These are what, we're not going to include that kind of stuff, right? And so your developer would be able to create this cluster deployment object, which is picked up by CAPI and Sveltos and deployed into a downstream environment. So that allows us to create essentially golden paths for provisioning downstream, provisioning and managing downstream clusters. So that's kind of a high level on Kordent. So now we'll kind of get into the live demo stuff. I do want to go over a couple tools if you want to kind of follow along here for kind of the workshop-y stuff. So one of the big things here is we're probably going to use like a Unix-like system. I think WSL will work. I haven't really tried it with WSL, but it should be okay, I hope. I'm doing a lot of this demo in Amazon, so it just because it's kind of fast and easy to get stuff up and running. We're going to be using EKS CTL specifically to spin up a cluster. Now, I've done a little bit of pre-work on this because this can take some time. So I will say there's definitely some paint drying parts of this demo, of this process. I will wait for people. If anybody has any like concerns, or if we're moving too fast, just let me know and I'll make sure to slow it down a little bit. And we'll make sure all this stuff kind of comes into play. So before I get started with the demo, are there any questions or anything like that?
Anything we should know about your CAPI provider? It sounds like it's custom.
So CAPI, we actually just use upstream CAPI, but oops, sorry, wrong button. So it's actually just upstream CAPI, but we can actually have so we did put in here, we do have the Cosmotron controller, which actually lets us do cool things like hosted control plane. You won't see that during this demo, but actually that's a really cool feature. But actually, the way we do this is we have all kinds of CAPI controllers. So that's that CapX, right? So we have like Kappa, CapK, Cap Elemental P, right? We've got the whole alphabet of providers that kind of just come with Kordent, like CapG and CapZ, all the major like cloud providers, and then even OpenStack, and we've even got a remote SSH provider, and we're working on a Metal 3 provider. So we've got a lot of providers, and actually that's kind of what makes this very flexible. This is all incredibly just it's just built on CAPI's incredibly flexible framework. So yeah, so the Cosmotron stuff is pretty cool because we have our own Kubernetes distribution called k0rdent. And Cosmotron allows us to do, essentially you can host inside of what we call this mothership cluster. That's specifically the terminology for it. We have this Cosmotron controller here that allows us to run control plane components inside of this cluster. So this works great for like bare metal clusters, for example, where if you have this, if you've got downstream worker nodes, obviously you don't want to be deploying entire worker nodes for just control plane components. That doesn't make a lot of sense. So you can have your workers be control planes, and they can actually be geographically distanced because of k0rdent leverages an upstream tooling called connectivity. So kind of like proxies requests back between the API server and the downstream nodes, making it so that we're not going to have like those huge problems you would have with stretched kind of cluster design. So in regards to that, but unfortunately, I don't have a lot of the Cosmotron stuff set up right now for this demo or anything like that. But yeah, future stuff, it'd be really cool to show that off. So
Okay.
yeah, perfect. Anything else?
Yeah, Sveltos is for guardrails. That's your component for that.
Sveltos is the component predominantly for just deploying. So it's kind of our so we have the controller in the mothership, and then we'll have a deployment, the agent in the downstream cluster. Sveltos specifically will just be for application deployment specifically. So when we're deploying applications, or when we're deploying the cluster, we can also deploy applications with the cluster, essentially. So things like, for example, I need Argo, I need Kyberno, right? Like those kind of things. So I can just go through and add those in, and those will just come when I spin up the cluster. The agent will handle making sure that those things are deployed. We actually have this here, and I can probably show this really quick. We actually have this thing called the Kordent catalog, which I probably should have just had this up and running. But we've got this kind of interface here, if you can see my screen okay, of just various applications we can just deploy from this catalog. And really what it is you will set, okay, that's kind of a bad example. This deals a lot. Let's grab Server Manager because it's really easy. But what you'll do is we create these things called service templates. And they're just OCI, they're just Helm charts. really, and then you'll put and we'll actually install a couple of these during the demo, so you'll kind of see what that looks like. And then when you create your cluster deployment object, you'll be able to specify like, hey, I need cert manager created from this template. So that's kind of the cool thing it provides. So you have that ability to, during the actual cluster creation, also be able to kind of specify the creation of these various Kubernetes resources at the same time and set their versions and stuff like that. All right, so I'm not sure if that answered the question. So guardrails, it might be a function or feature I'm not too aware of, but oh, it looks like there's a lot of stuff in the chat too. I'm sorry, I haven't been able to see the chat yet. Oh, okay. So this is kind of going back through some of this stuff. Thanks for chiming in. Yeah, I can't, the chat's not popping up unless I kind of like hide things. So I apologize if I wasn't able to get to questions earlier, but without further ado, then I guess we'll kind of get into this. I will say for a majority of this stuff, right? So the first thing I'm gonna have you do here, I guess is this GitHub repo, and I really wish maybe I could put this in the chat here. Sorry if I look like a bumbling idiot on a Mac. I'm really actually more of a Linux guy, so it's getting used to. There we go to chat, and then I'm just going to put this in there just so everybody has that. But if you go to that GitHub link and clone that repo, that'll kind of get us the files we need specifically in there. This is kind of the source code for all of the modifications we've done. Special thanks to like Barath, and this is Christian, who both of them were wonderful help on this. This is a lot of work. They did a huge amount. So specifically what we're focused on here is going to be this Kubernetes folder, which just kind of has all the resources in it. And I'll just kind of walk through. We're going to be using all of these resources in here. So just kind of setting stuff up. If you haven't already, I would go through the AWS configure process. Just make sure like your terminal has those, is configured with all that stuff. Your access key and all that stuff. And once you do that, I've actually done, just because this takes so long and I didn't want to be waiting for this during the demo, I actually did run through the provisioning of the actual cluster, and I just built this provision EKS script. Can you see my screen okay? I just want to ask this to everybody just to make sure. Can you see like what I'm typing? Is that okay? Does it need to be any bigger or anything like that? I think we have more chat messages. Perfect. Thank you. Wonderful. Okay, so in here, I have this script that's just provision eks.sh. The EK, this will just run eksctl cluster create. I should mention too that part of the dependencies here, we're going to need eksctl just because it's a fast way to spin up a cluster. Not doing anything fancy. We're just spinning up a standard cluster. It'll use the M5 large nodes for the default, but we can tear this all down later. So then we're going to pass in the name as the first parameter and then the region as the second parameter. So specifically what that would look like is just kind of scrolling back here. Is I just named mine BS Kordent, stage Kordent, and then US East 1, because that's actually the most local region to me. But wherever you're at too, you're going to want to just specify your region. So you'll be able to get that in just kind of your that B stage Kubernetes folder specifically. So yeah, I'll give that a minute and just kind of let people get kicked off with that. Are there any questions with that process or anything like that? Open chat again. Like we're good. Okay. So when this is all done, let me ask, should I go ahead here or should I wait just to kind of let people get started? Get a little understanding of where you guys want to, or where everybody's at right now. It's kind of hard to tell. Okay. I guess I will just kick off. So there's actually going to be, and I'll just say this, there's going to be 3 components that we're going to be installing inside of this Kordent cluster. Most everything command line wise, I've just kind of, now it's not pretty, right? I mean, obviously in a production environment, you use things like ingresses. You're going to use things like CI/CD pipelines. You're not going to do any of the stuff we're doing by hand, but for the sake of demo purposes, this should all be contained within this folder. So the big thing we're going to be there, the 3 components we're going to be installing are Kordent. That's kind of the big one. And really to install that, there's a script I have. It's just install -Kordent. And that'll be kind of the first thing we run through. And all that's going to do under the hood is just
So are we building control plane on top of this Kubernetes cluster to manage other clusters? Is that what we're
yes.
doing?
Yep.
Oh.
Yep. That is exactly it. Yes. But we're going to see too that, I mean, the control plane, right? We can put other things on the control plane. It's a very like flexible and modular control plane. So we're going to install a few other components within this that are going to kind of help us manage our downstream resources too. So, I don't know if you guys can see this. Just switch the windows really quick here, but this is really all the command is to install Kordent, and that's what's happening in the background there. So it's not anything too fancy. It's just a Helm install, but I just have that scripted, so you can just dot install that. Here, and then we can actually check the status of it's the resource. So there will be a resource here called MGMT that we can just check when it says ready. That is how we know Kordent is officially set up and deployed. It's going to be doing a lot of things, but what we can do in the meantime is we can check the pods in folder here, KCM system. It does take a couple of seconds, so that's kind of what I mean by paint drying type stuff. There's a couple things we can do in the meantime, just to kind of watch it. Couple things like the controllers will restart, but you'll see that it also does have a source controller, which comes from Flux. So we actually have Flux built into the cluster. If you want to do a lot more GitOpsy stuff, it's kind of just baked in there. But yeah, we have the controller manager, which is kind of the big thing. And then in a minute here, we'll actually see the CAPI controller kind of start to spin up. It takes a minute. Yeah, here we go. There it is. This should restart. Okay. Right, yeah, you'll see we have the cluster API operator in here. It's just for managing the resources. And pretty soon this namespace will actually have a lot of stuff around all the other CAPI providers we were talking about earlier, all the stuff that just kind of comes baked into Kordent. We have quite a few of them that just come in by default. So the next thing we can do in kind of the meantime here is I just want to get the kind of core stuff kind of baked in. So I'm going to end up creating a namespace here, and it's actually just a very simple namespace. So let's look at that namespace. Just Backstage Kordent, and that's where we're going to be actually deploying our Backstage stuff into. Geez, can't spell. Wow. Okay. So we'll get that namespace created, and then the other things we'll want to install here is in the kind of shorthand time here. There's another component called Cluster API Visualizer, which is a way we can actually graphically kind of interface a chart view of our Kubernetes clusters, and we actually have some integrations now with Backstage, so we'll be able to kind of see that in the Backstage interface. So I just put this in the install capev sh, and that, so we're same page. What that is this utility here, which it's just another Helm install, but it's going to pull from this repository. It's going to create the cape visualizer namespace, and then it's going to create a service type load balancer in this cluster too, and we'll see kind of how that's exposed here in a minute. But once we have all that in play, user. Let stuff kind of just bake for a second here. Sure, everything is kind of up and running. Yeah, there's all of our happy providers kind of coming in, so we can see all this is in play. Okay, I can see that it is true. So we are deployed with Backstage. That is great. All right. So there's a couple more auxiliary type things. So now what we're going to do is we're going to actually start the Backstage deployment type stuff. So Backstage itself is going to need some RBAC permissions. So I have this rbac.yaml file here that just creates Backstage. Don't worry about the naming. It's kind of, we didn't just messing around with names, but the service account stuff, it's going to create a cluster role and a cluster role binding for Backstage to be able to interface with the local Kubernetes cluster, which will allow us to create those earlier defined kind of cluster deployment resources and allow us to actually provision downstream clusters using Backstage. So I will just apply that RBAC stuff because we'll need that beforehand. And then if we look at our, and then one last thing we're probably going to kind of make sure we need first here is interesting. The service Backstage load balancer. So the way I expose Backstage in the cluster here is going to be via just a load balancer. Again, I know like you'd probably want to use an ingress. You'd probably want to do TLS certificates and stuff like that. It's just, yeah, we're just for demo's sake, we're just going to expose this via a service load balancer. And then I also have in here just this little get endpoints when this is all provisioned. And you'll be able to see that we have these two cluster IP endpoints, which if you just look at the get endpoint script here, it really what it is just getting the Backstage Kordent and the cape visualizer stuff. And the reason we're going to need this is because I'll kind of try to make this look a little bit more clean. In here. So we'll have, so we'll have to modify the deployment just a little bit before we actually go into, just before we go into some stuff. we have to set some values here. Just and this is kind of stuff Backstage needs. I was kind of looking into some prettier ways to do this. We'll have to kind of work on this and clean this up a little bit so we won't have to do this. But in the meantime, really we can use and don't worry about, these are just like old values, just as a frame of reference. Just make sure we, like, for example, when you're doing this, right, you have the HTTP on the front of it, and then the CAPI visualizer URL, we're going to want to make sure has that 8081. Because that's kind of how it exposes itself. So by default. So so here we've ran that get endpoint script, and we're going to grab the Backstage URL, which is this one, this long kind of just ELB kind of naming. Here. Not that for some reason, and I've been ghosty for some reason, has been putting off my first character, but we want to make sure to get HTTPS, not HTTPS, we're doing HTTP. It's just the front end here. Yeah. Oops. And then, of course, this last one, which is the CAPI visualizer endpoint, will just be this right here. That's what we're doing right now. Just make sure we specify the end of this. Characters. So we should have everything in play now, and we can see we have that service count from earlier. We're just using that to kind of reference Backstage, and this is kind of our. I'm gonna do that. Okay. All right. So with this, now we will go through the actual deployment of. Got everything here. Okay, so we'll just apply that deployment then. So now what should happen is you should be able to just go to this endpoint here. We're going, everything copies properly. Going to our browser. Yes, that is a force of habit. And yeah, it's broken. Hold on. Jeez. Real-time troubleshooting. Ah, there we go. Just took a minute. Okay. All right. So yeah, once we have this all kind of up, it's just going to look kind of generic. We haven't really implemented off into here. We'd like to kind of in the future maybe do something with like Dex and IDP and all that kind of or sorry, it's just off in the future. But right now, we've kind of been toying around with some observability stuff too with like open cost, but won't go into that quite as much. But the two things I kind of want to go into here is, so we should be able to kind of see our CAPI visualizer interface here. So we can see we just have like a management cluster interface in Backstage here. And this allows us to kind of get and when we create a downstream here, we'll be able to see the actual core functionality of that that Backstage, or essentially what this UI looks like, and being able to kind of go into stuff. It's kind of just generic right now because there's not a lot of stuff in play. The next part of this will actually be using the service templates here. We can deploy a variety of providers, and can I move this real quick? Okay, actually that's beautiful. Awesome. And so we can we actually created this little template plugin, and it allows us to kind of just configure some basic stuff like kind of region. For example, I like using the M5 larges. I know they're not great, but we can deploy into US East 2. That's kind of where I'm going to go. There is an important detail here is we are going to need an identity cred before we go and actually do this deployment here. And I'll go into that really quick. Obviously, I'm going to try my best to be secure about this and not like leak my credentials all over the place during this process. But I have this AWS creds directory here. And really what you're going to do is you're going to add in your access key and your secret key specifically. And right now I'm just pretty much using a root account for this. So this should have all of the required permissions it needs for just creating downstream clusters and things like that. So I'm going to go ahead and deploy this, but how I'm going to deploy this is using, I have some environment variables set up. So you'll see it creates a secret for our identity, and then it creates an AWS cluster static identity. So what these resources are here is this is just a generic secret that obviously contains the AWS secret. This, if you're familiar with CAPI, the AWS cluster static identity is kind of a CAPI CRD. Specifically, it tells CAPI what kind of resource and then references the secret itself. And then last, we actually have the Kordent resource, which is the credential, and the credential points to the CAPI object itself. So that's kind of how that kind of flow of secrets work. So there's 3 objects we need for that. And that's what allows this to be able to kind of like connect back to our authentication provider to be able to build downstream clusters. Perfect. So we should have everything in place, fingers crossed, because demo time. Okay, so let me grab this and get this out of the way here. So what we can do here too in this interface, and you'll kind of see this is a little bit going into the Svelte stuff. So right here, this configuration is going to go into our cluster deployment, but this also is going to go into our cluster deployment. And this is like pre-canned applications we can have, right? So one thing to note though, is that we actually can't deploy any of this stuff without the upstream cluster having cluster templates installed. And that's kind of where, when we were looking, for example, at these service templates, they you can kind of see that they have they make you do kind of like a Helm install here. And the reason for that is just basically so you kind of have like administrative control over what can actually be installed in play. I see there's a couple of comments, so. That is a really good question, Vijay, and I'd like to kind of clarify that none of this is very clean at the moment. We'd like to actually consolidate this into, so realistically, it's 3 applications, right? I mean, it's CAPI Visualizer, and the CAPI Visualizer stuff is kind of like none of this is exactly required, but you know, with there's a couple different processes we can kind of approach here. So the question, I don't know if you guys can see my chat up here in the window here, but the question really is just asking around maintenance, if it's going to be a maintenance nightmare managing all of these Helm charts. Obviously, I mean, like it depends specifically on how many Helm charts we're talking and what we're trying to do. This flow, and I really want to stress, right, like the Kordent process was it's really just one Helm chart, right? So Kordent itself is one Helm chart. Backstage, we have kind of a janky deployment process for this right now. So this is very ugly, and I do want to be clear with that, right? But in the future, what I'd like to kind of see with this and what I think we can kind of do is set this up so this is just one Helm chart. I'm just doing it manually kind of because I want to show you what the resources are. That's kind of one of the key parts of this, is to actually walk you through kind of what these resources look like. So we're definitely doing more of a deep dive or an in dive as to what actually is happening here in this deployment during this time. But yeah, like all the stuff like an ingress and all that stuff could just automatically be set up with a Helm chart. And we can set up a lot of this with just like automation with CI/CD. So using, you know, even the inbuilt Flux controller, we can just, you know, automatically pull in charts and kind of manage resources from that. Okay, the guardrails he's talking about, Backstage layer. Oh, okay. So I think so I hope that answers your question, Vijay. I want to make sure, you know, yeah, I'm able to get to all these questions here. And I do apologize sometimes I'm not seeing the chat, but so the other part of it, so Stephen here, this is a really good point too, kind of talking about Cosmotron. There's some really cool stuff with Cosmotron, and you know, I'm realizing now that I probably should have brought Cosmotron. It's really cool. It is really cool. It's something we really like to show off. It's a really neat little piece of functionality. Right now, we don't quite have the functionality built into Backstage yet, but it absolutely can be there. It's something that we could kind of like flesh out, and I think it would be cooler to see. For kind of the guardrail stuff, if we're just talking like big picture guardrails, the great thing about Backstage, right, is we're just deploying Kubernetes resources to Backstage. So right now, this interface we have in Backstage, like kind of what I'm talking about here, right? This is actually pulling from, and we probably should change this, but this is pulling from an upstream list in GitHub, but really where we'd like this to kind of pull is this is going to pull from the Kordent cluster itself, right? So the developer will only be able to see the applications that are approved and already exist within the cluster as per predefined as like the administrator put in there via the service templates. So you as the administrator would go in and say, okay, we want these applications, right? And then when the developer comes through this interface, you're going to kind of click on the applications that have been pre-canned or predefined, and that's going to kind of allow us to have guardrails as well, at least for the and I kind of hope that that's kind of where you're asking that question about with guardrails, but that allows it so that developers really are just going to have this golden path, right? So anybody able to use Backstage are going to have this very, very strict kind of like predefined path sourced off of how that actual upstream cluster is managed. Now, we've got really broad RBAC, but kind of going back to like the RBAC stuff we were doing earlier here. We can absolutely control how our RBAC interfaces with the cluster. So Backstage itself is not going to be able to go and modify those service templates. So as the developer, you can't go in and modify those service templates. You can only consume them. So that means that it's predefined, it's golden path, golden built, it's tested, it's the standard, you know what I mean? We can implement those things from a standard perspective. And then as the developer in the interface, we can consume them from a standard perspective. So I hope that kind of makes sense from kind of how that all is built out. I'm unsure if that answered your question, but I hope did that cover it, Stephen? Okay, I'm gonna move on. But so one last thing we do need to do in here is we should have a so I created this service templates just of two applications, which is Ingress Nginx and Argo CD. And you can see this is the Helm install commands for each of these. So I just created the service templates.sh script that we can run. And essentially what this is going to do is this is going to put the service templates, and they go really quick, right? So it's just from the upstream, like obviously you can take these internal into your own OCI registry, modify them, but these are just the upstream stuff from the from here, essentially from the Kordent catalog. So and we can kind of see them with kubectl get service. Yeah, and we need a namespace. VCM system, yeah. So so this will create you can see that these now are valid and they're able to be consumed. So actually, truthfully, the UI is kind of lying to me here. The only thing I can actually install at the moment is going to be these two applications, Argo CD and where is it again? I've done this a million times and I still can't find it. There it is, Ingress Nginx. So what we'll do then is we're going to go in here, and you can see we'll just have this little review page here. I just call it my AWS cluster deployment. AWS standalone control plane will be the actual. This is the this I guess I should go into also is, so just like there are application templates, there are actually there are templates for infrastructure. So we have infrastructure templates too. And this is the one that will allow us to deploy on EC2. This is just going to do a standard k0s install via EC2 using the AWS standalone control plane provider. So we'll have that. And this is going to be pre-baked into Kordent, so you don't actually need to like install these manually. They should just kind of exist when you install. And we can kind of see that too. Yes.
You mentioned three different templates: the service template, infrastructure template, and application template. Like, how are they different? How are they similar? Just confused.
Okay. So the infrastructure, there's actually two, right? So there's infrastructure templates, and then there are service templates. And I guess this is this is better visualized kind of on this page here. There's applications, which is just what we call services, right? It's kind of interchangeable. That's how we're using the terminology. Probably not the best, but it is very interchangeable here. And these are just our regular applications that we deploy after the fact in the cluster, right? So these are things like, you know, like OPA Gatekeeper or Cert Manager or Argo CD, right? You know, so those are kind of utilities you deploy in Kubernetes, right? And then the other part is going to be the infrastructure, and this is the kind of stuff that Cappy actually is going to use to configure to use a variety of providers for and you know, I want to drop this into the chat as well, just so you can all kind of look at this. I realize now that I haven't actually put this in the chat. So that this is the kind of stuff Cappy is going to use for deploying onto. So we can obviously do AKS, we can do EKS, or we can just do standard EC2 instances. We can just use standard VMs within Azure, GKE, or just Google Kubernetes, right? So just kind of that stuff. It's just essentially the CAPI providers. So the infrastructure templates allow us to predefine, but what this will actually allow us to do is we can predefine certain characteristics of, so for example, if I look at this adopted cluster object, which is the EC2, just for simplicity's sake, if I just kind of look at the YAML for it, that's the best thing here. Sorry. Or sorry, not adopting cluster. Jeez, that's what I'm doing wrong. Getting confused. We can see that there's certain, let's say, default configurations that will override in here, but this template allows us to define certain kind of certain required types of definitions essentially for the cluster deployment. So for example, like these are the this is going to be the default like CIDR for the cluster, right? These are where these IP addresses come from. So we have the 10.224 or 10, yeah. So this would be like our service range, and this would be like our pod range. So we could define that stuff. We could also define control plane configuration and all that stuff in the service template. So really what the service template object's job is it's kind of a wrapper for CAPI resources, and be able to pass in kind of like default predefined values. And then we'll be able to kind of override those or set those specifically. We're going to use those as part of our cluster deployment object, which once I get a cluster deployment object in play here, we'll see what that
So these
looks
are
like.
like from platform engineering paradigm, these are like those leaky abstractions, essentially. Like those are there, they have defaults, but you still can go down and kind of configure to a particular value, right?
Well, right. So there's various ways we can actually kind of control that, and we can kind of I see what you're saying, right? Yes, we can go through and modify some of the stuff from the template too. Part of the problem of what I'm showing here is things are very open, right? I'm not factoring in security at all into this demo. So I want that to be abundantly clear. Like we're using HTTP. Like that security is not, it's just a demo, right? So like, you know, if you tip this stuff over or whatever, it doesn't really matter. But there's all kinds of stuff we can actually do with this kind of template interface where we can restrict access or restrict certain predefined characteristics of these applications, these downstream kind of like actual how these things are deployed. We can control that using kind of this template method. So the template method just makes it easier for us to predefine golden paths. That's really what it is. It allows us to build predefined golden paths. So there's the deployment, which is like the executive action, right? And then you've got the you've got this template, which is kind of the golden, this is what you're going to be doing. And every deployment has to use a template. And you can actually kind of see this in the UI too. That's what I was kind of talking about here, where this is using that AWS standalone control plane template. So that is the default. Now like this is going to go into the KCM namespace. This is going to be able to override stuff. This is going to have all the correct characteristics to just clobber everything. I can set everything I want because I'm just basically running at this from the admin perspective. I'm not actually like doing security right now. You know, obviously if you're really doing this, there's many other ways you would definitely kind of approach this. And then yeah, you just want to make sure. Yeah, so like I see what you're saying with the kind of leaky abstraction stuff, but really what it is it's actually, it kind of allows us to be a little bit more flexible, but also restrictive, if that makes sense.
Yep, that makes sense.
Okay. All right, so this is just the confirmation page. Oh, sorry, go ahead.
Just want to wrap up. So we basically have the resource definitions which are given to us by cloud providers, right? We take those, we give them some defaults, we build a module out of by combining a couple of different resources, and then we wrap around that module. Let's say AKS module. I might want a log analytic workspace in Azure along with it, plus an Active Directory group. I pick those three different resources, put them together into a module, then wrap them around with this KCM template, and then that KCM template is what I'm going to deploy using Backstage. That'll be the one which will be exposed to the actual end user, right?
So kind of, yeah. So there's I guess I should go back here. I want to okay. Actually I have that all. Okay. So essentially how this is going to work is it's actually these are the three Kubernetes objects. It's just focus on this box here, this cluster definition box. Really what it is we have these cluster template definitions, right? So these are the things that the administrator provides. So essentially what it is you're going to come in, you're going to have Cappy is pre-installed in the cluster, Cappy, Sveltos, all your controllers are already there, right? So this is just configuration for Cappy. That's really what it is. And then this is just configuration for Sveltos. That's all that's going to be, right? So these templates allow us to kind of like administratively control defaults. So for certain aspects and overrides, what's going to actually be created by the developer is these cluster deployment objects, right? So these are the things that actually do the job of telling Cappy, hey, we need to create a new cluster. And tell Sveltos, hey, we need to deploy a new application, right? So this cluster deployment object is actually a wrapper for all of this stuff. You can kind of think about it as it's not really a wrapper, it's more just a reference to all of this stuff. So it's built from the service templates and the cluster templates to kind of simplify this. So realistically, the only thing anybody is actually thinking about from day to day is these cluster deployments. Well, the operators are going to think about cluster templates and service templates, but one-time early things, right? These are your golden paths. These are your actual workloads. That's your workload definition.
So in object, if we think about in terms of object-oriented programming, like these are the classes we are defining, then we create an object using that class and we pass it the required parameters and arguments and kind of instantiate an object out of that class. These cluster templates are like classes, right?
Yeah, you can kind of think of cluster templates as classes, except for I don't want to say it's a direct abstraction, right? So that's kind of the thing, right? I mean, a little bit of composition here. So we're so it's not a direct abstraction. So like cluster deployments are not built, they use like they reference, right? So it's a very horizontal, and that's kind of what I mean by as composition, right? They're going to reference the cluster template, but they're not a full-on inherit from the cluster template. The cluster template does define and certain, I guess you could say it passes things down kind of like an object-oriented manner, but these are coexisting in the cluster. That's kind of what it is, right? So yes, essentially you can think of cluster template, service template as classes, and then but it's not like one-to-one like with object-oriented, right? So you'd have it's more like many to one. So you're going to have all of these template definitions that end up being referenced by one cluster deployment object. The arrow is kind of backwards here. So the cluster deployment object itself is going to be able to kind of reference these resources. So
that makes sense. Thank you.
Yeah. So here I'm gonna go through because this can take a little bit too. But I want you to notice too, I actually deployed default in AWS, and I hope I'm still logged in here. I should be. I am in region 1 here. So Virginia, US East 1, right there. That's where I deployed this cluster, the Kordent stuff, the Kordent Backstage stuff. But I'm gonna actually deploy in a different region too, just to kind of show that that's a thing. And then we're going to deploy Argo and Ingress Nginx because we have those cluster templates in place. And we're going to see when I hit apply, it's going to say, yeah, I created this deployment resource, right? So on the back end, actually, before we go to do anything, this is where I want to show Cappy Visualizer really shines. So now Cappy Visualizer is going to automatically update and realize, hey, we've got a new object and it's provisioning. So we can actually, and it's going to be a little ugly now because there's no real control plane. So it's still trying to figure out what it's doing, but it's going to kind of tell us all the objects, and we can kind of go into each one of these and we should be able to kind of see the YAML when they come in place. Obviously, the stuff is going to look horrible and broken because nothing is in play at the moment. It does take a minute to provision these, but this is a 5-node cluster, three control plane, 2 workers by default. That's just kind of how the template is set up. I think it actually says that. Yeah, control plane 3 workers. But we'll see that here in a second. So that's going to provision that downstream cluster for us. But what we can do is we can just kind of kubectl get cluster deployments system. And you can see it's not ready. It'll eventually be ready once it actually gets in play. And because I am a very impatient person, I kind of like to watch this stuff in AWS itself. So we should start to see instance spinning up any minute here. It also needs to create all the networking stuff first. I will get into questions just a second here. I see there's some stuff in the chat. So let's go through that really quick. Yeah, so okay, to answer Stephen's question here, once you have the CAPI controller configured, you can consume any CAPI provider. I don't know if that extends to Cosmotron controller though. Yes, it does. Is it possible to develop other infrastructure provider templates? Yes. Alibaba. Actually, and a really cool story about that, William, I don't know if you're here, but one of my colleagues, William, has developed like in a day provider template. So like, yeah, it's really cool. You can provide CAPI is incredibly flexible. So really, really cool stuff. Where do we store the templates being built? Are those cached for such deployments? So the templates I would put in Git. That's what I would do because again, like all of this is just Kubernetes CRDs. That's the cool thing, right? And when I say Kubernetes CRDs, they're plain text, right? So that's cool. We can just store them in Git and we can version them. So just like we version our every other Kubernetes resource, we'll version our cluster templates. And we can even version our cluster deployments. Now, technically, I'd say we interface with cluster deployments more imperatively using kind of something like Backstage, right? It's kind of the Backstage interface here. Let's see here. So this should take a second. So are they cached, right? I mean, the reality is like, so those cluster templates exist inside of the cluster, and multiple resources will be able to, multiple cluster deployments will be able to reference those resources, reference those cluster deployments. So they're just going to exist as just kind of backing that up a little bit. They're just going to exist as these CRDs inside of the cluster. These are all just Kubernetes manifests. So cool thing is we store these in Git. We manage these through GitOps or like an OCI repository in this picture, right? Because we can also deploy them as Helm charts if we really want. I mean, that's how they're kind of deployed. And if they're Helm, we can use them as OCI objects and just kind of bring them into the cluster. So let's see if this actually goes. I don't know how much time we'll actually have to show the full cluster deployment. kubectl. So we can actually kind of watch the status of this stuff just using the Kappa controller. Oh no, these static credentials. Oh no. Okay, so you messed up my. That's what's going on here. I messed that part up. Source. Bear with me 1 second. don't validate this stuff. AWS creds. I'm gonna change this after the fact anyway, so no worries. I know this is base 64. Please don't hack me. Make sure it's there. Yeah, there we go. Perfect. Cool. All right. All right. So that should that should kind of kick off here. I know it's kind of a little bit of a waiting game now. I guess I could check the logs stuff. Let's see what we're doing. We'll just let it reconcile again, kind of keep the logs going. So yeah, that's kind of I guess I do want to kind of wrap up, be a little respectful of time. I know we're kind of running up on it here, so thank you all for kind of coming to join us here. I kind of have this little demo structure thing. I kind of want to wrap up by just saying, like, you can always reach out to me via my email at Marantis. Like, if you want to see anything, like if you want to see the Cosmotron stuff, I'd love to show that to you too, and like kind of get that. We probably have better like ways to show that stuff. And if you have any suggestions for kind of the direction you'd like to kind of see this Backstage stuff go, we could definitely we really want to hear feedback on that.